Hey everyone, I'd like to welcome you all back to my lab. In this episode, what we're going to do is we're going to talk about function generators and what they're actually used for, and also look at arbitrary signal generators. So if some of you have been keeping track of what I've been doing, I bought this function generator / arbitrary signal generator here probably about 3 months ago, and I know how to use some of the functions just off of being able to use function generators from before. However, though, there are some new things in this function generator that I've never used before. So what I'm going to do is, as I'm learning how to use these different functions and so forth from the function generator back there, I'm actually going to be teaching you how to use it also. So again, in this episode, what we're going to be looking at is my function generator, and it's a Siglent SDG 1032X. I'm going to start off in this video with the very bare basics, what a function generator does, how this actually does those, and then in future weeks what I'll be looking at is some of the really cool features that have been added to the function generator, and as I learn how to use them, I'll be teaching you how to use them also. So come right back after this message and we'll get right into it, start talking about function generators. So a function generator is an electronic device that's used to generate a variety of representative waveforms. These waveforms include sine wave, square wave, and triangle wave. Some function generators can also generate sawtooth and pulses. Let's take a look at this function generator. It's made by BK Precision. It's the 4011A. On this function generator, you'll notice that it has the ability to make 3 different waves: a sine wave, a square wave, and a triangle wave. Alright, so now let's take a look at what used to be, or what was my original function generator. And so here you'll notice that it also can do the 3 waves that the previous function generator can do. It can do a sine wave, can do a triangle wave, and it can do a square wave, and it can also do TTL, which stands for transistor logic. The new function generator that I purchased, and here we go, this is it. I'm going to zoom in just a bit here. So it also has the ability to do a number of waves, and I'll go ahead and show you what waves it can do. So I'm going to hit the waveform over here, and then I'm going to zoom in just a little bit. You can see that it can do a sine wave, square wave. This is it says ramp, but that's the equivalent of triangle. It can also do pulse, noise, and then we can go to a second menu over here where it can do DC, and it can do an arbitrary wave. So why the name function generator? Well, the waves generated by a function generator can be represented by mathematical functions with respect to time. So for example, a sine wave, as many of you may know, has a function of AP times sine omega t plus theta, where AP is the maximum amplitude, omega is the angular frequency, t is the time, and theta is a phase shift. A triangle wave can be represented by the function AP times 2 over pi times the inverse sine of sine omega t plus theta. And a square wave can be represented by the mathematical function AP times the sine, meaning negative or positive, of whatever the resulting expression of sine omega t plus theta is equal to. Okay, so in the previous segment, you may remember that I talked about the amplitude and frequency that were a part of the equations that could be used, the mathematical equations that can be used to represent these functions. I also talked about the phase. You may change the parameters of the signals that are being generated from the function generator. So if we look at this function generator, you'll notice at the top here that if we wanted to change the frequency of a signal that's being generated, we can use this frequency range, the frequency range buttons here, as well as these knobs to adjust for frequencies from 0 hertz up to 5 megahertz. If we want to change the signal amplitude, we may turn this knob here in order to change a signal amplitude. So let's take a look to see how we would do that on the function generators that I own. Alright, so on this function generator that's on my cadet board, you'll notice that there are two slide knobs here, one that's over here and one that's over here. And so these two slide knobs, what they're for, or we'll call them slide knobs. What they're for is this one is for changing the frequency, and along with this one I can also change the frequency from kilohertz down to the hertz range. And there's also these three switches that are, or pardon me, not these three switches, but one switch with 3 positions that's for 1, 10, and 100, so I can actually multiply whatever frequency is being generated over here by 1, by 10, or by 100. Okay, so if I slide this, put that in combination with this and this, I can actually change a frequency. Over here I can change the amplitude of the signal that's being generated. So let's go ahead and set this to a frequency here, and we'll take a look at our function generator, or the signal that's being generated by our function generator on the oscilloscope. So I already have the function generator connected to the channel 1 of my oscilloscope. And so if I roll up here now, and I'll have to make some adjustments to the camera. All right, you'll see that the signal that's on the screen there, and it's coming in on channel 1. Coming in on channel 1, and we can tell that it's coming in on channel 1 by looking and seeing that there's a 1 there in that corner. And what you'll see here is that I can increase the amplitude or decrease the amplitude. I can increase the frequency or decrease the frequency, and I'm just doing this by simply sliding the slide knobs here on this function generator. Now let's say we want to look now at this newer function generator, which I told you is so much better than what I used to have, and honestly it's a pretty decent function generator. Alright, for the new function generator that I bought, if I want to change the frequency on this, okay, I can just, you can look right here and you'll notice that frequency is in blue, and up here frequency is also in blue. So I can change the frequency on this by doing one of two things. I can go over here to this knob and I can turn it, and you'll notice that the frequency is changing as I turn it. Okay, the second option, another way to change it would be to come in here and type my new frequency. So I can type 2 and then go over here and tell it that the 2 that I typed in, I want it to be kilohertz, and now it's set for 2 kilohertz. Okay, and so once my signal is set, I'd make sure that my output button here is on in green, and then from there I can then go send that to my oscilloscope. Now currently my oscilloscope is showing what's in channel 1, which is coming from the old function generator, but what I'm going to do is I'm going to change that so I can get a signal from channel 2, And so that's a signal from channel 2, but it's it's not syncing for channel 2. So I'm going to change my triggering source to channel 2. And you'll notice now that I've created that sine wave with a frequency of 2 kilohertz. And that's the signal that's at the bottom, by the way. Okay. And again, that is coming from the function generator that's here, and it's going into channel number 2. Okay. So that's like super easy. So let's say I wanted to change my signal's frequency, but rather than having the frequency information, maybe I just have the period information. I can go over here and click on period. Once I've gotten to period, I can then, let's move the camera over just a little bit. I can then hit my arrow keys underneath here, so that it goes over to the first digit, and then I can type in my value. So I can type in 400, let's say, and then say that I want that to be microseconds, and it's going to put in the period of 400 microseconds in there. And then from there, then that's going to be the signal. It's going to be 400 microsecond signal that's going to be shown on my oscilloscope on channel number 2. It's just that simple. If I wanted, let's say, to change change the period but use the knob instead, I can just simply change this. And this is going to take a long time, but you get the idea though. I can also change that, and that would change the period of my signal by turning the knob. Alright, so there are some other parameters that may or may not be available on certain function generators. On this model here, you'll see a couple of them that are available on some again and not available on others. The first one would be the DC offset. And for the DC offset, you would turn the knob here, but before you do that, you'd have to tell the the function generator that you want to adjust the DC offset. What the DC offset does, by the way, is just simply moves the signal, or adds a DC voltage to the signal, which is equivalent to moving the signal either up or down relative to the 0 point or the ground point. And I'll show you what that's like on the oscilloscope when I actually look at my new function generator. Second parameter that you can change on some function generators is the duty cycle. Now the duty cycle is available, or it's used more for when you're working with square waves. And the duty cycle, we'll talk about that in a little bit. For this, in terms of the duty cycle, what you'll need to do is you'll need to actually hit the button here first in order to indicate that you want to use duty cycle, and then you'll turn the knob. So the duty cycle is a ratio between the high level of a square wave and the period of that square wave. So in other words, duty cycle is equal to TH, which is the high portion of the square wave, over the actual period of the square wave. Okay, and so let's now go ahead and look at both of these functions, or both of these parameters on the new function generator. Okay, so we're just going to look at the new function generator because the old function generator doesn't have any of those functions that we just talked about. So first one that we looked at on the in the prior segment there was the DC offset. And so if you go and click over here, you'll notice now it says DC offset. You'll notice here also that it's showing that we have the offset, or we're capable of changing the offset at this point. So what I'm going to do is, and before we do that, actually let's just look up at the signal here, and you'll notice that the signal, according to this, the ground line is coming in at this point right here. And so the sine wave is about that ground line, around that ground line. So it's evenly it's right in the middle. So if you look from the bottom to the top and top to the bottom, it's even between the two. Okay. Now, if we go down here now and change our offset from being 0, let's go ahead and change it to something. Let's go ahead and just change it to 1 volt DC, 1 volt, and then we have to tell it that it's 1 volt and not a microvolt in DC. Now that we've done that, you'll notice that if we go up here, the signal went up by 1 volt. Okay, now I can bring that signal back down, and I'm just going to turn the knob, and I'm going to leave it up here. And so I turn knob, you notice that the signal went back down. All right, in order to see that, by the way, the signal that's coming in here and is coming in on channel number 2, all right, that actually needs to be DC coupled, so you can see the DC signal that's coming in. Again, we can change that to add a volt onto it, so it went up by 1 volt, or it hasn't actually yet. I have to tell us that it's VDC, and then once I do that, it goes up by 1 volt, and I can bring it down. Okay, so that's a DC offset that's being added, and I can add that to a sine wave, triangle wave, or the square wave. Now, the other thing that we talked about, and I'm going to go back down here to the function generator. We talked about adding a change in the duty cycle, right? And so we said for a duty cycle, we need to be on square wave. And so if you notice here right now, there's no duty cycle related to the square wave. It's not shown on the screen. So let's go now and change the duty cycle. So we have to go to type of wave first. And so in order to change the wave, I gotta go to waveform over here. Okay, and then I gotta tell it that I'm using a square wave. And if I go to square wave, you'll now see that duty cycle showed up. And so it says that the current duty cycle is 50%. So if we go up here, it looks to be about 50%. That means half of the signal is high. And so now if we change that, so let's go ahead and change that now. So I'm going to go over here. I'm going to go to duty cycle. Now you'll notice that the duty cycle in blue is on. And so I'm going to decrease it. And you'll notice actually it's actually giving me sort of like a graphic to show me what it should be looking like on my oscilloscope, or something similar anyway. And so it should look something similar to that. And if we go up here, you'll notice that my duty cycle actually did change. And so I can increase it, or I can decrease it. And again, my old function generator could not do that, but some of the more expensive ones could. And to be honest with you, since that function generator was in the prototyping board, you don't expect a whole lot from it. So the old function generator did what it was supposed to do. It's just that this one is so much better. And okay, so we talked about duty cycle. Let's go back to the sine wave. I'm going to go back to wave generation over here, and I'm not going to actually show you this because you know how to do this at this point, or you know how I did it anyway. So I'm going to go back here, change to sine wave. And so one of the things that we can change here is we can change the phase. And so I can change the phase to be something else. And by the way, it won't actually show up on the oscilloscope, because remember, the oscilloscope is actually syncing up to a specific point on the wave, but you'll see that it's actually changing it on the screen here below. So it started off looking like a sine wave, and if I bring it all the way over here till about, let's say about that, or actually I can actually change it to 90 degrees. Yeah, there it goes, 90 degrees. Then it looks like a cosine wave that's on at least this screen anyway. Again, it doesn't make sense to show it to you on the oscilloscope because the oscilloscope is syncing up to a specific point, and it's always going to show that, so it's not going to show it up there. All right, so so that's the phase. So that phase there is actually some extra stuff that we can do. What I find also that's pretty cool And so let's go here now to the triangle wave. So I'm going to go back over to waveform. I'm going to change the waveform over to triangle wave, or the ramp as they call it here. And so now that I've changed it to ramp, you see that it says that it should be a ramp there. And I go up here to the top. Let's see. I go up here to the top, to ramp, and back down here. I'm going to turn the brightness back down so you can focus a little bit better. All right, so I can actually change the symmetry on my ramp, okay? And so by changing the symmetry, and as a matter of fact, what we're going to do is, let me just take you up to the oscilloscope and show you what's going on the oscilloscope as I change the symmetry. So I'm just going to change the symmetry by turning the wheel or knob at the bottom there. Oops. Okay. Oh, changing the frequency. I am so sorry. All right, let's go ahead and put it back to 1 kilohertz. Or I'm going to change to 1 kilohertz. Bear with me. Frequency 1. Change to kilohertz. All right, there we go. And so now I'm going to change the symmetry. There we go. And so look, now look what happens to the wave as I do that. And so right now it looks kind of like a sawtooth, doesn't it? Okay, and I can take it over to the other direction. Let's keep changing that. You'll see that it turns back into something triangular shape, and then it continues going on. And again, 100% that way, too far. All right, and so you can see that it changed the triangle into something sawtooth-ish looking. And so, man, these are some pretty cool stuff that we can do with the function generator. And the funny part is, this isn't even half the stuff the doggone thing can do. There's a few more things, and I guess what I'll do is I'll save those for the next edition. So come back next week and see what else we can do with this function generator. And FYI, you'll notice that on the function generator down here, it does say that they say function generator. I'm going to scroll right up there. It says function generator. I'll do one more time. It says function generator / arbitrary waveform generator. So it can create these functions that we were talking about, but it can also create, you know, just arbitrary waves that I decide I want to make up. So again, this is what makes this stuff really, really cool, especially to someone who studied signal processing for a long period of time. This is pretty cool. So anyway, come back next week. We'll talk about some more stuff that we can do with this function generator / waveform generator. I'm excited about it. I hope you are too.